Air France Flight 447 mysteriously crashed in the Atlantic, killing 228 people. Now, with the flight recorders finally recovered from the ocean floor, we know more about what happened in the final harrowing moments of that Rio to Paris flight.
What's happening? We've lost control of the aircraft. These were the desperate words from the cockpit of Air France Flight 447 as it plummeted into the Atlantic Ocean on June 1, 2009. The crash claimed the lives of all 228 people on board and left the aviation world reeling.
Air France Flight 447 has been a mystery. The plane went down off the coast of Brazil, killing all 228 people aboard in June of 2009.
How could a cutting-edge Airbus A330, piloted by an experienced crew, suddenly fall from the sky? This is not just a story of tragedy. It's a story of mystery, human error, and systemic failures. The investigation that followed revealed shocking gaps in pilot training, unexpected vulnerabilities in modern aircraft, and lessons that would forever change the way we fly. May 31st, 2009, 7:29 p.m. local time. Air France. Flight 447 departed from Rio de Janeiro's Galeão International Airport, bound for Paris. On board the Airbus A330 were 216 passengers from nearly 30 nationalities.
Air France Flight 447 took off from Rio de Janeiro, heading for Paris Charles de Gaulle Airport. It was an Airbus A330-200 series, carrying 228 people,
including business professionals, vacationers, and entire families. The aircraft was equipped with two General Electric CF6 engines and had undergone a major overhaul just a month prior. The cockpit crew comprised 3 pilots: Captain Marc Dubois, with nearly 11,000 flying hours; First Officer David Robert, with 6,000 hours of experience; and junior co-pilot Pierre-Cédric Bonin, relatively new to the A330, with 87 flight hours on the type. Following standard long-haul protocols, they planned to take turns resting during the 12-hour transatlantic journey.
Pilots fly in shifts to stay alert. There are 216 passengers on the 11-hour flight. Autopilot holds the plane steady at 35,000 feet, and the crew communicates with Brazilian air traffic control.
Takeoff proceeded smoothly, and by 8:30 p.m., the aircraft was cruising at 35,000 feet. The flight appeared to be another routine crossing of the Atlantic, but as they entered the Intertropical Convergence Zone, a region notorious for turbulent weather, conditions began to shift. The Intertropical Convergence Zone, ITCZ, is a band of low pressure near the equator, where trade winds from both hemispheres collide, creating towering thunderstorms and heavy turbulence. While these storms are common, navigating through them requires careful use of onboard weather radar. As the crew monitored the developing weather, they discussed climbing to 37,000 feet to avoid the worst of the turbulence. However, due to warmer than expected air, the aircraft couldn't generate enough lift for the climb. The captain, trusting his team, left the cockpit for a scheduled rest, leaving Bonin and Robert to manage the flight. What the crew didn't know was that they were flying into a deadly combination of weather and mechanical failure that would soon test their abilities to the breaking point. As Air France Flight 447 cruised over the Atlantic at 35,000 feet, everything seemed normal. The autopilot managed the aircraft, and the crew monitored the weather ahead. But at 2:10 a.m., as the plane entered a patch of turbulence in the Intertropical Convergence Zone, a seemingly minor issue set off a catastrophic chain of events. The pitot tubes froze. These small yet vital sensors measure airspeed by detecting the pressure of the air flowing around the plane. When they froze, the airspeed indicators became unreliable, and the autopilot immediately disengaged. Now, the pilots had to take manual control of the Airbus A330, a situation they were trained for, but unprepared to handle under such conditions.
That has led some to speculate that the plane may have been hit by lightning. Although jets like the Airbus A330 are built to withstand lightning strikes, it's not a very uncommon occurrence. A search has now been mounted off the coast of Brazil and off the coast of Africa as well.
With autopilot off, the plane shifted into alternate flight control law, a backup mode that limited some safety features, including stall and bank angle protections. Bonin, the least experienced of the three pilots, was at the controls. Confused by the sudden failure of their instruments, he instinctively pulled the nose up, a dangerous reaction. The stall warning began blaring, signaling that the plane was losing lift. But in the chaos, neither Bonin nor Robert seemed to grasp the severity of the situation. Instead of lowering the nose to regain airspeed and stabilize the aircraft, Bonin continued pulling back on the controls, further exacerbating the stall. Robert tried to intervene, but their dual control inputs, uncoordinated and conflicting, only worsened the situation. The A330 climbed steeply, reaching an unsustainable altitude before beginning a deadly descent. By the time Captain Dubois returned to the cockpit at 2:13 a.m., the plane had already lost significant altitude and was in a full stall. The cockpit was filled with warning alarms, flashing indicators, and the sounds of the stall warning repeating over and over. Despite Dubois' years of experience, the lack of communication and the chaotic environment left him unable to correct the situation in time. The A330 continued its uncontrolled descent, dropping at a staggering rate of 10,000 feet per minute. As the crew struggled to make sense of their instruments and regain control, the ocean loomed closer. In their final moments, Bonin exclaimed, "We're going to crash. This can't be true." At 2:14 a.m., after a terrifying 3-minute plunge, Flight 447 hit the Atlantic, claiming the lives of all 228 passengers and crew. The events that unfolded in the cockpit highlighted a troubling mix of instrument failure, human error, and lack of training. While the frozen pitot tubes initiated the crisis, the pilot's inability to recover from the stall was the direct cause of the crash. The investigation would later reveal a glaring issue. While pilots were trained for stall recovery at low altitudes, they received minimal training for high-altitude stalls, where conditions and responses are vastly different. This critical oversight would become a focal point in understanding how such a modern, advanced aircraft could succumb to disaster. In the early morning hours of June 1, 2009, Air France Flight 447 began a terrifying descent from 38,000 feet. For 3 minutes and 30 seconds, the Airbus A330 hurtled toward the Atlantic Ocean.
Can't speculate, but you can only imagine the fear factor and the terror. These poor passengers, 3.5 minutes, you say this plane was descending at a rapid speed?
No, it was not descending at a rapid speed. It was just descending at 38,000 feet to the ocean in 3 minutes and 30 seconds.
At a near vertical angle, its engines operating but unable to provide lift due to the stalled wings. Inside the cockpit, confusion and panic reigned. The first officer repeatedly pulled back on the controls, trying to climb, while the stall warning blared continuously. The aircraft's pitch fluctuated between 10 and 16 degrees nose up, far too steep for the plane to recover. Meanwhile, the plane's descent rate exceeded 10,000 feet per minute, with the horizon spinning wildly outside the cockpit windows. As the plane fell, one of the most critical issues was the lack of clear communication between the pilots. The first officer and relief first officer both made control inputs, often at the same time. In Airbus planes, when two pilots move their side sticks simultaneously, the system issues a dual input warning. Despite this alert, the pilots continued making conflicting adjustments, further destabilizing the aircraft. The captain, upon returning to the cockpit, tried to assess the situation, but received little explanation. In the chaos, he asked repeatedly, "What's happening?" Yet neither of the other pilots could provide a coherent answer. One critical oversight: neither pilot explicitly acknowledged that the aircraft was in a stall. Despite the stall warning sounding over 75 times, they failed to execute the standard stall recovery procedure, which would have required lowering the nose and increasing airspeed. At 10,000 feet, the aircraft was still in a full stall, with the nose pointed upward and the engines thrusting at nearly maximum power. The Airbus was no longer flying but plummeting, its aerodynamics disrupted by the stalled wings. The ground proximity warning system activated, issuing urgent commands to pull up, pull up. Desperately, the pilots applied maximum thrust and attempted to level the plane, but it was too late. At 2:14 a.m., Flight 447 slammed into the Atlantic Ocean at nearly 200 miles per hour. The force of the impact shattered the aircraft, scattering debris across the ocean floor. All 228 passengers and crew perished, making this one of the deadliest crashes in Air France's history. The disappearance of Flight 447 shocked the world. For days, search teams scoured the Atlantic, finding only small pieces of wreckage and a few bodies. It wasn't until 2 years later, in April 2011, that the bulk of the wreckage, along with the flight data recorders, was discovered nearly 4,000 meters below the surface. The discovery of the black boxes would finally provide answers to what happened during those final, fateful moments.
The black boxes could provide vital information about why the plane went down. Without them, accident investigators have focused on automated messages sent by the plane minutes before it lost contact.
When Air France Flight 447 failed to arrive in Paris on the morning of June 1, 2009, a massive international search and rescue operation was launched. With the aircraft having vanished over the Atlantic, authorities faced a daunting challenge. The crash occurred in a remote area of ocean, far from radar coverage or eyewitnesses. For 2 days, search planes and naval vessels scoured the waters off the coast of Brazil. On June 3rd, search teams discovered light debris and an oil slick, offering the first evidence of the crash. Personal belongings, fragments of the aircraft, and the bodies of 2 passengers were also recovered. But the majority of the wreckage, along with the crucial black boxes, remained elusive, hidden deep beneath the ocean. The search for Flight 447 quickly shifted to a high-tech operation. The ocean floor in the crash area was an underwater mountain range with depths reaching nearly 4,000 meters. Specialized vessels equipped with sonar and remotely operated vehicles ROVs combed the seabed for months, but progress was slow. By mid-2009, the initial search effort ended without success. Frustrated but undeterred, investigators launched additional missions over the next 2 years, employing advanced technology and international expertise. On April 3, 2011, after nearly 2 years of searching, a breakthrough finally came. A French research vessel, using sonar-equipped autonomous submarines, located the main wreckage of Flight 447. The debris field lay scattered across a rugged section of the ocean floor, over 13,000 feet below the surface. The discovery of the wreckage reignited hope of uncovering the truth behind the crash. Just days after the wreckage was located, search teams recovered the aircraft's flight data recorder, FDR, and cockpit voice recorder, CVR. These black boxes, designed to withstand extreme conditions, were remarkably intact despite spending nearly 2 years in the ocean's depths. Once brought to the surface, the recorders were sent to France's Bureau of Inquiry and Analysis for Civil Aviation Safety, BEA, for analysis. Investigators now had the tools they needed to reconstruct the final moments of Flight 447. Beyond the black boxes, other key parts of the wreckage provided valuable clues. Investigators noted that the engines were intact, ruling out an explosion or mechanical failure. The position of the landing gear confirmed that the crew had not attempted a water landing, further supporting the theory of a high-speed impact caused by a loss of control. With the black box data and physical evidence, investigators began piecing together the sequence of events that led to the tragedy. Their findings would soon reveal a chilling combination of instrument failure, human error, and inadequate training.
Some areas of the bottom here are almost 3 miles down. Searchers will be listening for the automated ping that the boxes give off.
The recovery mission was not just about finding answers, it was also about bringing closure to the victims' families. In total, 154 bodies were eventually recovered, allowing many families to properly mourn their loved ones. The painstaking efforts of search teams, spanning years and costing millions of dollars, were a testament to the aviation industry's commitment to learning from tragedy and preventing similar accidents in the future. The analysis of Flight 447's black boxes painted a grim picture. This was a disaster caused by a lethal combination of instrument failure, pilot error, and systemic shortcomings in training and safety protocols. One of the first findings was the failure of the pitot tubes, which had frozen over due to ice crystals in the turbulent weather. This disrupted the airspeed readings, causing the autopilot to disengage and leaving the pilots to fly manually in a high-stress situation. While the pitot tube malfunction was a known issue with the Airbus A330, the investigation revealed that pilots were not adequately trained to handle such an event. Perhaps the most shocking discovery was the crew's response to the crisis. Despite the repeated stall warnings, the pilots failed to recognize that the aircraft was in a full aerodynamic stall. Instead of taking corrective action, lowering the nose to regain airspeed, they continued to pull back on the controls, worsening the situation. Investigators noted that neither Bonin nor Robert had received proper high-altitude stall recovery training. While they were trained to handle stalls at lower altitudes, where recovery is more intuitive, they lacked the experience to deal with the unique conditions of a high-altitude stall, where the thinner air makes recovery more complex. The inquiry also highlighted a breakdown in crew resource management, CRM. The lack of clear communication between the pilots, along with conflicting control inputs, further compounded the problem. The captain's absence during the critical moments of the crisis underscored the importance of maintaining effective leadership in the cockpit. Another key issue identified was the crew's over-reliance on automated systems. Modern aircraft like the Airbus A330 are designed to minimize pilot workload through advanced automation. However,
First Officer Pierre-Cedric Bonin is 32 years old. He's been flying the A330 for about a year.
We are arriving at Intol.
37-year-old relief pilot David Robert is on standby.
this can lead to a dangerous situation when pilots are suddenly forced to take manual control. The investigation revealed that the pilots were overly dependent on the autopilot and lacked confidence in their manual flying skills. This dependency on automation, coupled with inadequate training, left them ill-prepared to manage the situation when the systems failed. In July 2012, the French Aviation Safety Agency, BEA, published its final report on the crash of Flight 447. The report contained several critical recommendations aimed at preventing similar tragedies in the future. 1. Enhanced stall recovery training. Pilots should undergo regular and mandatory training for high-altitude stall recovery. Simulators should replicate realistic scenarios to help pilots build confidence in manual handling during emergencies. 2. Improved pitot tube design. Airlines and manufacturers were urged to replace existing pitot tubes with models less prone to freezing in extreme conditions. 3. Angle of attack indicators. The BEA recommended installing angle of attack indicators in cockpits to provide pilots with clearer information about the aircraft's aerodynamic status. 4. Better crew resource management. Training programs were revised to improve communication and coordination between crew members during high-stress situations. 5. Upgraded flight recorders. The BEA advocated for flight data and cockpit voice recorders with longer recording capabilities and enhanced durability to withstand extreme conditions. The crash of Flight 447 was a wake-up call for the aviation industry. Airlines and regulators around the world quickly adopted many of the BEA's recommendations. Stall recovery training became a cornerstone of pilot development, and improvements in cockpit technology, such as better pitot tubes and angle of attack indicators, were implemented across fleets. This tragedy also sparked a global conversation about safety culture in aviation. The focus shifted from merely preventing mechanical failures to ensuring that flight crews were equipped with the skills and knowledge needed to handle emergencies effectively. The crash of Air France. Flight 447 marked a pivotal moment in aviation history. It underscored the dangers of over-reliance on automation, gaps in pilot training, and the critical need for better understanding of high-altitude stall recovery. While the tragedy claimed 228 lives, its aftermath brought significant changes that continue to shape the way we fly today. One of the most far-reaching legacies of Flight 447 was the overhaul of pilot training programs. Before the crash, high-altitude stall recovery was rarely emphasized in training. Following the BEA's recommendations, airlines worldwide began implementing mandatory simulator exercises that mimicked real-life stall scenarios at high altitudes. Pilots now undergo rigorous training to recognize and respond to stalls, with a focus on lowering the nose and regaining airspeed, key actions that could have saved Flight 447. This shift in training has greatly enhanced pilots' confidence and competence in manual flying during emergencies. The crash also prompted improvements in aircraft design and technology. Pitot tubes, which had a history of freezing, were replaced with more resilient models capable of withstanding extreme weather conditions. Additionally, many aircraft now feature angle of attack indicators, providing pilots with crucial real-time information about the aircraft's aerodynamic performance. Another significant change was the enhancement of flight data recorders, FDRs, and cockpit voice recorders, CVRs. Modern recorders are now equipped with extended recording capabilities, ensuring that vital data is captured even during lengthy flights. Perhaps the most profound impact of Flight 447 was the shift in the aviation industry's approach to safety. Airlines and regulatory bodies recognize the importance of fostering a safety-first culture, where addressing potential risks and learning from past incidents take precedence over operational efficiency. This cultural shift encouraged greater transparency in incident reporting and a renewed focus on crew resource management, CRM. Improved CRM training has helped pilots work more effectively as a team, ensuring clear communication and coordinated decision-making in high-pressure situations. The lessons from Flight 447 extended far beyond Air France and Airbus. Aviation authorities worldwide, including the European Union Aviation Safety Agency, EASA, and the Federal Aviation Administration, FAA, adopted stricter regulations and guidelines based on the BEA's findings. These measures fostered greater international collaboration in addressing safety concerns and implementing best practices across borders. While technical improvements have made flying safer, the legacy of Flight 447 also emphasizes the importance of the human element in aviation. No matter how advanced the systems, pilots remain the final safeguard in ensuring the safety of every flight. The tragedy served as a sobering reminder that human error, if unaddressed, can have catastrophic consequences. Beyond the safety reforms, the legacy of Flight 447 is also about remembering the 228 lives lost. Memorials have been erected in their honor, including a commemorative monument in Rio de Janeiro and a memorial near Paris. For the families of the victims, these memorials serve as places of reflection and a reminder of the importance of continuing to improve aviation safety. Today, the lessons of Flight 447 resonate across the aviation industry. The changes it spurred in training, technology, and culture have made flying safer than ever before. Though the tragedy will forever remain a dark chapter in aviation history, it serves as a powerful reminder of the importance of vigilance, preparedness, and the relentless pursuit of safety in the skies. The legacy of Flight 447 is a testament to the resilience of the aviation industry in turning tragedy into progress. As we reflect on this story, we honor those who lost their lives by ensuring that the lessons learned continue to guide and protect future generations of travelers. The crash of Air France Flight 447 was more than just an aviation disaster. It was a wake-up call for the industry. The combination of mechanical failure, human error, and inadequate training revealed vulnerabilities even in the most advanced aircraft. Yet, from this tragedy emerged significant reforms that continue to safeguard millions of passengers every day. The story of Flight 447 serves as a sobering reminder of the delicate balance between human expertise and technological reliance. While automation has transformed air travel, the crash highlighted the critical importance of manual flying skills and clear, decisive communication in the cockpit. As the world watched the aftermath unfold, the loss of 228 lives sent shockwaves across the globe. Each passenger and crew member had a story, a family, and a life filled with hopes and dreams. Their memory serves as a powerful motivator for the aviation industry to never stop striving for improvement. Memorials and tributes stand as symbols of remembrance, but they also serve as reminders of the responsibility that comes with every flight. Every innovation, every safety protocol, and every piece of training is a testament to their legacy. Today, the skies are safer because of the lessons learned from Flight 447. Airlines and regulatory agencies worldwide have adopted stricter protocols, enhanced pilot training, and improved aircraft designs. While no flight will ever be completely free of risk, the advancements made in the wake of this tragedy have significantly reduced the likelihood of similar accidents. The legacy of Flight 447 is not just about tragedy, it's about progress. It's a reminder that every lesson learned, no matter how painful, brings us closer to a future where air travel is as safe as humanly possible. As we reflect on this story, let us take a moment to appreciate the immense complexity of aviation and the dedication of those who work tirelessly to keep us safe. Let the tragedy of Flight 447 serve as a beacon for continuous learning and improvement. If you found this story compelling, consider subscribing to our channel for more investigative stories that uncover the truth behind aviation's most mysterious and impactful events. Together, we can honor the past and embrace a safer future.